Sup nerds, it's Lindsay. So I'm gonna be taking you through a little of my MCAT studying from today. So today I was focusing on the behavioral sciences. That's actually not a big problem area for me. That was one I have always done well on, but I just want to make sure I'm getting all that review done before I really dive into some of my more problem areas, which tend to be more like biochemistry, physics, those sorts of things. So let's start with the organization of the nervous system. So there are three major types of neurons in the nervous system. The motor neurons, or the efferent neurons, the interneurons, and then the sensory neurons, or the afferent neurons. So once people get a little mixed up, of course, is when we get into efferent and afferent. So the efferent neurons are the motor ones, the sensory neurons are the afferent ones, and then there's interneurons in between. Then moving on into the two branches of the autonomic system, we have the parasympathetic branch of the autonomic system and the sympathetic branch of the autonomic system. So the parasympathetic branch is the one that's focused on rest and digest, as we like to call it, and the sympathetic is the one that's focused on fight or flight, as we like to call it. So the parasympathetic system, what does that actually do to your body? Let's go ahead and go through the list. It constricts your pupils, it stimulates the flow of saliva, it constricts bronchi, it slows your heartbeat, it stimulates peristalsis and secretion, it stimulates bile release, and it contracts your bladder. Conversely, if we take a look at the sympathetic system, the fight or flight one, it really does the opposite of all those things to your body. It dilates your pupils, it inhibits salivation, it relaxes your bronchi, it accelerates your heartbeat, it causes sweating, it inhibits peristalsis and secretion, it stimulates glucose production, it stimulates the secretion of adrenaline and noradrenaline, which is probably something that we would imagine was something in a fight or flight system. It inhibits your bladder contraction, and it also stimulates orgasm. If you didn't know that, that's that sympathetic system. So just a little side note here. I feel like there's something here with this whole parasympathetic system stimulates the flow of saliva, and then the sympathetic system inhibits salivation. I feel like there's some like really pretentious insult in there. If like someone's being like a thirsty bitch, you say something like, oh, you got an overactive parasympathetic nervous system, or conversely like an inactive sympathetic nervous system. I don't know, there's something there. It needs a little work, but that's just a little side note. Moving on to the organization of the brain. So we organize the brain into the hindbrain, the midbrain, and the forebrain. Forebrain, not the Ford brain. There's not a Ford logo there. Oh my gosh. I can talk like a human person, I swear. I'm very new to doing videos, as you know, if you watch my channel, and so there is like a nerve component that goes in there. Like a few people have commented that I can't seem to just keep looking at the camera. My eyes are always like darting all over the place. It really is just pure nerves. I'm working on it, I promise. It's just hard for me to do this, sit down and talk directly to a camera. Anyway, back to the brain. The hindbrain contains the cerebellum, the medulla oblongata, and the reticular formation. Moving forward into the midbrain contains the inferior and superior colliculi. And then the forebrain contains the thalamus, the hypothalamus, the basal ganglia, the limbic system, and the cerebral cortex. Okay, so going into those different parts of the forebrain and what they're all about. The thalamus is the relay station for sensory information. The hypothalamus maintains homeostasis and integrates with the endocrine system. The basal ganglia smooths your movements and helps to maintain your posture. The limbic system controls your emotion and your memory, and that's where you find the septal nuclei, the amygdala, the hippocampus, and the fornix, which is something that we'll get into a little bit more later. Then the cerebral cortex is divided into the frontal, parietal, occipital, and temporal lobes, which we'll also get into later. So starting with the parts of the limbic system, this is where we find the septal nuclei, the amygdala, the hippocampus, and the fornix, okay? So the septal nuclei is responsible for pleasure seeking. The amygdala is responsible for fear and aggression. The hippocampus is responsible for memory, and the fornix is responsible for communication with the limbic system. Once again, I feel like there's some really like pretentious Shakespearean insults in there somewhere about, you know, if someone's being aggressive, like make some sort of crack about their amygdala being overactive, or like someone has really bad memory, something about there being something wrong with their hippocampus. I feel like there's something there. I mean, if y'all are picking up what I'm putting down, let me know in the comments, please. Then within the cerebral cortex, we have those 4 lobes that I mentioned earlier. The frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. The frontal lobe, that's really the guy in charge. It's the executive function, the impulse control, the long-term planning, the motor function, and the speech production, which is specifically in the Broca's area is your speech production. Then the parietal lobe, we have the sensation of touch, pressure, temperature, pain, and spatial processing. The occipital, you can probably imagine with that word occipital, like ocular, that is going to be visual processing. The temporal, over here, sound processing. That's the auditory cortex, speech perception. We've got memory and emotion there as well. Okay. And then, okay, what else do we have here? Sensation and perception, influences on behavior. I'm not going to go through literally everything that was on the MCAT quick sheet from Kaplan, but I'm just going through some of the big parts that I've been looking at today. So, or parts that I think can be a little difficult. One other tip that I have for doing MCAT studying, and this may not work for you, and different things work for different people. Obviously, we all process information in different ways, and we all understand things in different ways. But from Kaplan, I got these MCAT quick sheets, which is where a lot of this came from. And what I've done is I have taken all that information and written it into this notebook here. And the reason I do that is because I just find that I process information a lot better when I can see it in my own writing and in my own words. Also, I can organize it sometimes in ways that make a little bit more sense to me. Like, once again, we all process information in different ways. So sometimes I just the way it's organized in here, the way it's presented in here doesn't make as much sense to me as a way I could organize it differently. Also, I just like doing color with it. I find that to be very helpful. So that's one thing I do that is something you could potentially try. Then we've got hearing, object recognition. Let's talk about conditioning and stimuli. So classical conditioning. This is one that I think a lot of people are very familiar with because it's like Pavlovian conditioning. So it's called when you have an unconditioned stimulus and then you have a conditioned stimulus. That's the difference there. It's when you have an unconditioned stimulus, like the ringing of the bell would be an unconditioned stimulus, but then once you attached the idea that ringing the bell presents food for the dogs, that's when you get a conditioned stimulus. It becomes a conditioned stimulus. And then we also have operant conditioning. But let's go ahead and talk about stimuli for a second. So this chart here, this is pretty similar to the way it's presented in the Kaplan sheets. So we have up here, we have the stimulus, whether the stimulus is added or removed, and then we have the behavior, whether we do that when it continues or we do that when the behavior stops, basically. So if the behavior continues and then you add a stimulus, that's positive reinforcement. If the behavior continues and you remove a stimulus, that is negative reinforcement. Down here, if the behavior stops and you add a stimulus, that is positive punishment. If the behavior stops and you remove a stimulus, that's negative punishment. So this can be really confusing for a lot of people because people, first of all, this can seem kind of like redundant when you talk about negative punishment, and then this seems kind of oxymoronic when you talk about a positive punishment. You think, how can there be a positive punishment? So we need to kind of change the way we think about those words of positive and negative and reinforcement and punishment. So basically, anytime you are adding something, adding some sort of stimulus, that is always going to be something positive. Think about that, like adding is positive. And anytime you're removing a stimulus, good or bad, that is going to be negative. And then looking at the behavior, anytime the behavior continues and you are doing anytime the behavior is continuing and we're doing something, that is reinforcement. And anytime the behavior stops and we're doing something, that is punishment. Okay, so that's a new way of thinking about it. You have to really kind of change the way that you're thinking about those words. Sleep waves. Then let's go ahead and take a look at drugs. So looking at different drug groups, we've got depressants, stimulants, opioids, hallucinogens, and also marijuana down here at the bottom. Opioids has been a big topic lately because, especially in America, there's been a lot of opioid crises. So that's something that people have been talking about a lot. That's been kind of the reason for the synthesis of drugs like naloxone, or Narcan, I think is the brand name for it. So that's been one of the reasons for the synthesis of that drug. It's a really amazing thing, naloxone, is that it can basically immediately counteract the effects of an opioid overdose and pull someone out of an overdose by working as an inhibitor, I believe. I think it binds to the receptors and prevents the opioid from binding. So that's a really amazing drug that has come out pretty recently. I'd highly encourage you to do some more research into it. I think it's just very interesting. I don't know how much of that will really turn up on the MCAT, but I think it is very interesting. Piaget's stages of cognitive development. Yeah, that's Piaget. Piaget. Stages of cognitive development. This is something I find very interesting. So he has these different stages of development that I think about it sometimes in the context of like how a lot of different psychologists come up with stages of development. Like there's Freud, there's Erik Erikson, there's Jung. This is Piaget's way of looking at things. So his bottom level stage is the sensory motor stage, which focuses on manipulating the environment to meet physical needs through circular reactions, and object permanence ends this stage. So basically, once a child or a baby grasps object permanence, that is considered the end of the sensory motor stage. From the sensory motor stage, someone goes into the pre-operational stage. This focuses on symbolic thinking and centration, and also on egocentrism, which is basically the inability to imagine what another person is thinking or feeling, really an inability to see things from another person's perspective or put yourself in their shoes. And I think it's pretty obvious to everyone that some people never develop beyond this stage. Moving on, theoretically, you move from the pre-operational stage into the concrete operational stage, which is when you start to understand feelings of others and being able to manipulate physical or concrete objects. Finally, once the final stage of development, according to Piaget, is the formal operational stage, which focuses on abstract thought and problem solving. So ideally, a person will reach that final stage of development, but I think it's pretty obvious that not everyone does. Alrighty, problem solving, decision making, all very important. Attention. Another thing I think is really interesting is ideas of selective attention and divided attention. So selective attention is basically the idea that when there are multiple stimuli occurring, you can focus on one particular thing. And you notice that some people really are better at this than other people. Some people can study when there is the TV on in the background or when there's people talking out in the hall. Some people can still pay attention to what they're doing. They have that ability to determine what stimulus they should be focusing on, and some people just do that better than others do. So that comes down to selective attention. Then there's also divided attention, which I think is more what we would consider like multitasking in a colloquial phrase, because that's the ability to use automatic processing to pay attention to multiple activities at the same time. So once again, some people are better at that than other people. Language areas in the brain. You've got the Wernicke's area, the Broca's area, and the arcuate facialis. Oh my gosh, it's hard for me to say words and I'm kind of nervous. I swear when I'm not nervous, I can actually say these words and sound like a smart person, but the arcuate facialis. Okay, you know what? I'm just going to go ahead and move past that part. human memory, I think this is a very helpful chart. This is also from the quick sheets. I basically just like rearranged it a little bit in a way that made a little more sense to me and used color to kind of help me understand it a little bit more. So that's another thing with memory. Is that the end of this section? I guess that is. I kind of breezed through this. Sorry, I was talking kind of fast. That wasn't intentional. Let's see if there's anything I can go back to talk about a little bit more. Yeah, let's talk a little bit about sensation and perception. So these concepts of threshold, Weber's law, and signal detection theory. So the way we understand the word threshold for MCAT purposes is, its definition really is the minimum stimulus that causes a change in signal transduction. So basically the minimum amount of stimulus that you require for you to notice that something is there, or that something has changed, really. Weber's law states that just noticeable difference for a stimulus is proportional to the magnitude of the stimulus, and that this is proportional to that this proportion is constant over a range of possible stimuli. So basically what Weber's law is saying is that the greater a stimulus, the greater that just noticeable difference, the greater that threshold is going to be. Signal detection theory is a theory, obviously, that studies the effects of non-sensory factors such as experiences, motives, expectations on the perception of stimuli. Well, because basically what signal detection theory is saying is that there are other things at play going on behind everything here, other things in your mind that affect the way you perceive stimuli beyond just your neuron response, if that makes any sense. I hope so. All right, so this one was a little rough. I know, this is the first one. I've tried to do like a sort of study with me sort of video, and I know this one was a little rough. I'll try to get better at it, just because making a video like this I think really helps me to grasp the information better, and I hope it helps someone out there maybe grasp the information a little better just by hearing it in different words and a different voice, and by seeing the way I've written it out. I don't know. Maybe no one learned anything. But anyway, I had a lot of fun, and I hope the rest of y'all have a good day.